Hey everybody, this is Neil with Catalyst Machine Works, and what in the world is this thing on your screen? Well, we're really excited about this guy. This is a brand new design from us. We're going to release it for pre-sale today, and it's called the STIGG 195, so 195 millimeters from prop to prop. So why does it look so strange? What is the purpose of this? Why did we create this, and what's the reasoning behind this design? So some time ago, within our company, we had a discussion about these power systems. And we noticed that in a very short time, pretty recently, these motor manufacturers and ESC manufacturers have, and prop manufacturers have made a leap in the amount of power that these things can create. We're seeing combos now that can create, 1,400 grams of thrust per motor on 4S power, which is unbelievable. That wasn't even heard of a few months ago. So what is going to happen in a short time is that we're going to start seeing a plateau where you can't squeeze any more power per this weight out of these systems. All right, you can get them more efficient, you can tweak them there and whatever else, but you can't get any more power out of them. That's coming. So what we wanted to do is start looking at the frame itself and the losses that are incurred, the thrust losses incurred in the frame itself. And you do have losses in these frames. It's not an ideal scenario. So currently manufacturers, the way that the power to weight has been defined, or the thrust to weight if you want to refer to it like that, is you take the thrust that this motor can produce, the peak thrust, in a test stand scenario, which is a pretty ideal scenario, times 4, divided by the all-up weight of the system. But that's not completely accurate, because you're not accounting for the losses that are incurred when you take the volume of air and you move it by way of this prop through the frame. So after you do that, there are certain losses that are incurred. So typical flat plate frames, if you take this plate and it's perpendicular to the thrust vector, you have nearly a complete loss of thrust in this area, in this surface area. So you're taking your power that you had and you're reducing it. You have losses. So what we did is we took those plates and we rotated them 90 degrees. So you can see when you look at the profile of this thing, into the thrust vector, into the quote-unquote wind, as you'd call it, is there's very little cross-sectional area obstructing thrust that's produced by the system. So you have a higher net thrust to weight ratio. Right? And so that is really how the power systems as a whole, as a complete system with the electronics and the frame, should be defined, is net power to weight. You have to consider the frame itself because it plays a big part. All right, so I'm going to quickly discuss some of the features of this craft that make it unique. A big one here is that in an effort to keep as much material out of the line of thrust so we have as efficient of an airframe as possible, is that the ESCs are sitting at the center fuselage box. We call it a center fuselage box, you can see here. That does two things. It's taking as much mass as possible and packing it into as small an area in the center as possible, so your flight characteristics are ideal. Then we take the wires for the ESC and we run them under the arm. So that's keeping them out of the airflow. Right? They're sort of hiding behind the arm. The next thing about this guy is that it's very modular. So when you're racing, you have this structure here, this brace, this outer brace. If you, let's say, smash into a tree and you break this thing in half, it literally takes you about 2 minutes to replace it. Right? So you don't have to go and And like some of these mono frames that are an X frame, but they're completely all one piece. If you crack something, you're toast, you're out. You have to go replace everything, and it takes forever. This, if you break it, these 4 screws come out, you put in a new one, it takes 2 minutes, you're back in the air. That's it, it's easy. If you break one of these arms, which is pretty unlikely, we have yet to break one of these arms, and we've been flying it for a little bit now. It's easy to replace, right? You take these 4 screws out, take these out, you can pull this arm off once you take all of this bit out, and then put a new one on, right? No big deal. Now, since this is so modular, if you're not into racing, or maybe you race sometimes, the other times you're out in a garage somewhere smashing into concrete over and over again, you can replace these with whatever thickness you want. So they come. This frame comes with 3mm thick. We're also going to sell pretty soon. Well, once it goes for up for sale, we're going to sell the optional braces that are 4mm thick and 5mm thick. That is very rigid. You're going to be hard pressed to break that. All right. So another thing about this guy is that it does accept camera mounts. It's designed for racing. There's a weird geometry, but we went through great lengths to figure out how to get a camera mount on here. The first one that we're going to release with this is the GoPro Session mount that you see here. We're also going to release a RunCam Fox ear mount, which is that long camera. And then finally, we'll finish up and release the regular standard GoPro mount. Another great feature of this system is the adjustability of the FPV camera. If you've been racing for any length of time, you've realized that for different racing situations, you need different angles on the camera. I mean, if you're in a very close-quartered interior of a building or something, you're not going to need a crazy angle here. You're going to be going a little slower, so you're going to need to adjust that angle. Or if you're out in an open track and it's a big, smooth, open track, and you really want to haul some butt, you might want to put this at the max angle possible. So you want to be able to do that quickly. What we did is designed a mount that is a swivel mount, and this particular mount fits this HS 1177 camera. And one screw here, you unscrew this, and then you can adjust this. So this is adjustable from 20 degrees all the way up to 45 degrees. You don't have to use this camera. It's a little ring that fits this standard sort of barrel size of the lens. So any camera that'll fit in here, you can put it in there. Another thing that is really cool about this system is the way that the FPV antenna mounts here. So it makes it a very resilient, it sort of guards the antenna. In some systems, this antenna is just kind of hanging out there, and so when you hit this, it puts a moment on the structure that's holding the antenna itself, and you can break this off or break your antenna. But the way that ours runs is out the back here and up through, and then you zip tie the sort of at the middle of the antenna to this little standoff. So that's like a stress reliever. So when you hit and you roll over and this thing gets knocked like this, all the stress is running through this structure and not this structure, so you're not going to break this down here. That's really important. All right, so the last thing I want to talk about is a question that I'm sure a lot of you are thinking to yourself after seeing this, is that, well, it's going to fly weird. I mean, look at the arms. They're at this weird angle, and so when the air hits it, isn't it going to take it and spin it or do something strange in the air, cause problems? Well, no, it doesn't. Actually, this thing flies amazing. We've been, test flying it now, and it is fast as all get out. Unbelievably fast. Flies great. The way that air flows over these frames is not at some, angle to the plane of the frame. All right, when you're flying this thing through the air like this, you would think, but your intuition would tell you, well, the air's coming in here and it's going to hit this and spin it or do something strange. But actually, the airflow runs through this thing exactly perpendicular to the plane of the frame. So if the camera is where the air is coming from, it goes in this direction, right? Because what actually is happening is that these propellers are taking the surrounding air and they're redirecting that air perpendicular to the plane of the frame. Right? Now you do have a little bit of airflow that's running through here at an angle, but with regards to these arms, air is running in this direction. So we're very excited about this guy. We cannot wait until the general public can get their hands on this and go out and fly it, because we have been having an absolute blast. It is so fast, and it handles just unbelievably well. So, you know, not to sound corny, but our dreams really have come true with regards to this design. Can't say enough about it, but I'll let the proof is always in the pudding. So once you guys get your hands on it, go out and test it. You know, you can tell us if you like it or not, and I'm positive you will. Get on the floor like I said before.